HAIDLMAIR is a company that produces between 250 to 300 tools a year. We're known to be one of the highest quality mold makers around the world. And also, we have different companies around the world that allow us to optimize our tools for a higher quality. So right now, I can tell you that HAIDLMAIR, it is in Nürnberg, which is between Vienna and Salzburg, very close to a part of Austria, mid-Austria, called Linz. Our turnover yearly, it's about 65 million only for HAIDLMAIR. And we also have a workforce of about 300 people in Austria. It went back. Thank you. Okay, so this is HAIDLMAIR. So we have 9 different companies. These 9 different companies provide different services for our customers and for HAIDLMAIR as well. So one of them, for instance, HTM, they do the plates for our tools in Hungary. We also have another company, Digital Molds, which is in Germany as well. And we provide this box, which is it's called Digital Molds. It's a box can monitor your tools for actual values, for positioning, so GPS. And also, it would allow you to provide all the actual values for speed, pressures, temperatures. So I always ask my customers, how many molds do you have? And they say, well, I don't know how many around the world. And I said, where are they? Are they in China? Are they in Taiwan? They say, I don't know right now exactly. Then I asked them, are they running? And they said, I don't know. So if you don't know how many, where they are, and the status, then you need this box, because this box works directly with the cloud. It's installed in our tools or any other tool, and it provides all that information to you through an iPad. So you could have access to each mold, and it will tell you if it's running or not. All the rest of the monitoring services like cycle time and speed and flow and temperature. So this is what we call digital molds. Then we also have this company called FDU. And FDU is a company that is based in Germany as well, but it's owned by HAIDLMAIR. What we do is we provide hot runner systems. And the difference between this and any other hot runner is that we have a gap, a flat injection point, when other hot runner manufacturers provide a round injection point. And we're going to discuss this later on. Now, what HAIDLMAIR does, if you see all these companies like Orbis, like Monoflow, all these companies buy tools from us in Austria. We have a service center in Charlotte, North Carolina, that provides service engineering changes, preventive maintenance programs to keep these guys producing their parts so you can buy the bins and crates and trays and so on. Right now, we have just purchased 20 acres in Indiana, about 1 hour south of Indianapolis. We're going to be building our headquarters for North America within the next year. So we're going to start building this year, and we hope that by the end of the spring next year, our facilities will be completed. And this is going to be to provide the service that the North American customers require. So it's going to save you money and time as well if we produce in North America, made in the US with the Austrian technology. This building is going to also be hiring about 28 people to start on the building of the tools. Now, what is it that we produce? We produce bottle crates. We're the largest manufacturer of beer crates in Europe. And we've been doing this for a long time, so we have the expertise and the experience. Another thing is the rigid containers. So we have the rigid containers there on the second picture. And then we also have collapsible crates. All those crates are molded in the same mold at the same time. We also have pallets. Pallets of different kinds, different sizes, heavily used with regrind, a lot of PCR materials. And also we have big boxes to transport vegetables and fruit as well. Recycling containers like trash bins, the ones that you have outside your house with the wheels, we also do those molds. And also as well for water technology, that's for drains underneath the cities to protect the pipes and hoses and so on. We also do automotive molds. We just finished building the biggest mold ever produced, and this is a 130-ton weight mold. And this is gonna be injected on a 12,000-ton injection molding machine. So when people come to us, it's because they need to do something nobody else has ever done before, and also that we can provide the expertise because of the complexity that these parts require. That's how HAIDLMAIR is known to the top manufacturers around the world. We have molds in 100 countries around the world. And we have developed different technologies and a lot of features to save our customers to sell their products at a low cost because it's gonna cost them less during the savings of producing these molds. So HAIDLMAIR, what we do is not only build the tools like any other tool maker, but we provide services that no one provides at all. So one of them, for instance, would be the development and optimization, meaning that we optimize the parts even before they begin to be built. We want to make sure that we look at every single defect that could come in the future. And that is during the development and optimization. The simulations, every single tool that we make, we provide simulations for warpage to make sure there's not going to be any type of internal defects. And that's going to help the customers to avoid problems once they're running their tools. So it is a very difficult job to do when you don't have an actual part. We do prototyping on 3D. We have the biggest 3D machine in this type of industry, and that also is liked by our customers. We have the CAD designers. We have over 30 CAD designers in Austria. And then we also have the CAM programmers for our 3, 4, 5-axis CNC machines. As far as the production, we have been doing this type of technology and building this type of molds for 45 years. So we have those expertise already. As far as assembling, our assemblers play a really important role into the building because they have to make sure that the quality expected by our customers is met. As far as sampling, we have 7 injection molding machines from 175 tons to 3,200 tons. So we're able to do the sampling in Austria so the customers can get their samples, they can test their samples, and then they can come back and make changes if they wish. Also, we do scanning. So just like if you go to a doctor and you have a scanning done to any part of your body, we have a scanner that we scan the parts with to make sure that the internal defects are taken into account. So that's what we do with that. Now we're going to talk about the FDU. The FDU means flat. It's a flat die unit. Why is it flat? Because as you can see, the injection point is flat. It's a gap. It's not a regular point like any other hot runner. Now, some people would say, what is a hot runner? Well, a hot runner is a part of the mold that is utilized to transport the material from the nozzle on the injection molding machine until it reaches the cavity, that opening. So during that period of time, we have to keep the material melted, liquefied. And that's why we use that. The only difference is that the FDU makes the injection point flat to allow more material to go through that little hole, to fill faster the cavity, and to provide more pressure so the part is filled properly, 100%. So FDU, it's based out of a city in Germany called Frankenthal. There, the engineering and design engineers take care of all those services. And then we also have the assembly. The assembly happens in HAIDLMAIR, in Nussbach, in Austria. All the parts are developed, built, and constructed by us in Hungary. So we have another facility that provides that to us. Now, what you see here is a nozzle. So the nozzle on the right-hand side is what it used to be a nozzle. And then here on this side, you see what we call extrusion. Extrusion is a different method of injection, which means it's how we make pipes or plastic bags. It's a non-stop plastic passing. So, like I said, like how you make a pipe or a hose. That die, we came up with the idea, or why not instead of doing the film, why don't we do it for injection molding? And that's how we came up with the FDU, which is the nozzle that you see in the middle. And that's what we're going to talk about. As you can see here, on the right-hand side, that's a round nozzle, it's a conventional nozzle, and on the left-hand side, you see the FDU, which is the flat nozzle. So it's bigger, it's wider, and it's flat. And that's why we call it flat die unit. This is a video that will tell you about the benefits of the FDU. So during the injection cycle of any part, we have essentially two major parts of the cycle, which is one is the injection, one is the hold. Meaning we have to put the material into the cavity as fast as we can in a safe way that we don't develop any defects. And also the holding part, which is going to hold that material inside the cavity before the gates freeze. So meaning we have to pack that plastic in there. So we're going to talk about the injection phase. Here we see the differences between the two different hot runners. One that is round and one that is conventional. I'm sorry, the one that is round conventional and one that is flat. So on the right-hand side, you see the round nozzle, the conventional nozzle. On the other side, you see the flat nozzle, and you see the pin inside, and then the gate, our pin is flat. So there's more passage of material. And since there is more passage of material, there is less obstruction, meaning that there is less pressure. And since there is less pressure, there is less friction because there is less flow or speed. And that's how we came up with the FDU. Now, as you can see, the green line represents the FDU, the blue line represents the conventional round gate nozzle. So as we speed the injection, the shear rate, the heat goes up on the round nozzle. On the FDU nozzle, it remains constant, going slightly higher. And this is one of the reasons why it is easier to pack the cavity, because we have less loss of pressure because there is less shear. Now that we're talking about temperature, on the right-hand side is RDU, means round die unit. The round, you see the red, that's the heat that is being created because of the shear, meaning that there is an obstruction of material because the gate is small and is round. The other one is flat, is bigger, so there is less temperature. And that's exactly how we come up with higher flow, higher speed, less pressure on the nozzle, but more injection in the cavity. So we're able to not only reduce the cycle time, but we're also able to reduce the overall injection time. This is how they look like, the injection phase for the FDU and the injection. So there is less cooling on the walls as the part is injected, the plastic is injected on the FDU. On the round nozzle, the plastic starts, as it enters the cavity, starts to cool faster. And that creates more issues with defects during the injection. Now we're going to talk about the holding. The holding pressure is the highest pressure during the cycle, meaning at the point where you reach that peak and then you go into hold. So since there is less pressure during the passage of the material through the gate, if you don't need much pressure, then you need less tonnage or clamping force. And that sometimes you're able to cut the tonnage on a machine using our nozzles from 200 to 300 tons, just for that reason. So there's more savings. Here, we're going to talk about the cross-section of the nozzle, and this is very important because the loss of pressure which occurs at the nozzle, on the first picture on the right-hand side, for a round nozzle, you lose about 6,092 psi in this gate that we're sampling. We have two sizes in the FDU. We have the MIDI and we have the Maxi. The Maxi is, of course, a larger nozzle. And on the MIDI, we lose 5,366, which is less than on a round nozzle. But if you use the FDU, you're going to be losing even less, 3,356 psi. So there's more. The convenient thing about using the FDU is that there is less loss of pressure than with a round conventional nozzle. Now, during the holding pressure, the material remains hotter. As you can see on the round nozzle, the material remains colder as it enters the cavity, and on the FDU, it remains hotter. That allows you more precision, more control about having control of the cavity as the cavity is filled. Now, these are the products that we have. We have open nozzles and we have closed. So what we mean with an open nozzle is that it's always open, the nozzle. But with the we call the SLS, that is the valve gate, meaning that we're going to inject, then we're going to close the gate, meaning the pin is going to close the gate, right? So we can start fitting the screw back again. So this is very important because also provides some savings as far as the cycle time is concerned. Our two nozzles that we have, and this is also very important, the actual melt channel on the smaller one is 16 millimeters, on the larger one is 24 millimeters. Now, when we're talking about a regular hot runner system, We have exactly the same components as any other hot runner system, except of the yellow and the red one, meaning that the pin is different at the end, and also the sleeve is different because it is flat. And that's basically the only difference. It has an actuator as any other hot runner, and our hot runners are only hydraulic. We don't have pneumatic hot runner nozzles. Here is the comparison, and as you can see in the Maxi at the end, the last two, the very last one, our slot dimensions, because it's an elongated gate, is 25 millimeters by 4.1 millimeters, meaning that the cross section overall is 102.5 square millimeters. In order to reach that in a conventional nozzle, you will need to have a nozzle of 11.42 square, in diameter, 11.42 millimeters. And that is not likely to happen most of the time. Right here, you see the difference once again, that the FDU technology offers more flow, less shear rate, less temperature, less pressure, but more speed, meaning that we're going to inject as fast as we can. Also, at the end, where you see the red colors, the higher heat transfer, meaning that it's easier to get rid of the heat with the FDU than with a regular nozzle if it had to be 11 millimeters. So that's what's extremely important. The FDU also as well has the ability to have this cooling jacket. This cooling jacket is at the tip of the hot runner. And what it does, it allows us to cool right at the injection point, because as you can see, it's got two different materials, right? So we have brass, we have copper, and we have steel. This technology, HAIDLMAIR is the one that has developed this technology around the world. Out of all the tool makers around the world, there's nobody who can do this. Only HAIDLMAIR. We own this patent. And what this does is allows you, if you touch it, it's cold already. It's steel, copper, and brass. So this allows you to have more control over the cooling. At the same time that is doing that, it creates more longevity as well. And this is what we use for the nozzle, and we use also this technology for all our inserts and parts of the tools. That is called laser tech. We have a machine that provides the powder, and it's a laser welded part. Once it's welded, once the laser welds all the materials, the same machine does all the cutting in the same machine after that. During the injection, if you're injecting fast, there is something that we call as small defects, it's jetting. We don't have jetting because our gate is bigger. And if it's bigger, there's more material passing through it. This is a flow analysis that we did. We performed this flow analysis to make sure that there was no jetting, and in fact, there was no jetting, so there is less defects, molding defects during the process of injection. Thank you. Next, these are just some samples of some parts that we have worked on using the FDU. So right here, the FDU, the injection is happening right on the gate. So I gotta get down to show you. So what this does, the injection gate is on the rib. Instead of round, you can hide it in there. It creates a better processing conditions. Here, the gate is on this part, on this side, again, is going to provide less stress and less hot points. For those manufacturers of skids or pallets, the gate is bigger, so you can put PCR, regrind, material that has been processed again and again and again to save money. The gate provides that ability to have more flow. Right here, one of the things that we see again is a gate using PCR, which is a material that has been already processed. It is heavily used for that reason, to allow more material to go through the gate. Here on this one, so since the gate is bigger, we're able to reduce the number of nozzles. So normally, if a part has, let's say, 6 nozzles, injection points, with this nozzle, we're able to only put 1 nozzle. So you have a reduction of the cost. Less nozzles, less cost. This one went from 12 nozzles to 8 nozzles. In this injection, we had a reduction as well of material. This one had 6 nozzles. We reduced it to only 1 nozzle, and it was a 6.5-pound part. So it's heavy. It's an ABS. This one has a video that I wanted to show you really quickly. This video was done not by HAIDLMAIR, by our customers, and it shows the significant benefits of using FDU Hotrunner than a conventional nozzle. So we cool faster, we inject faster, and we have better control over the processing capabilities. So we're going to click. So this customer, they created this video to show their customers. This part is for a washing machine. Thank you for coming and listening to what I had to say about HAIDLMAIR and our technologies. Thank you.